You are listening to Agile Simplified, a practical guide for modern teams. Subscribe to keep up to date on our latest audiobooks. Agile Simplified, a practical guide for modern teams. Chapter 1, The Agile Revolution, Why We Needed a Better Way. Imagine a world that changes at an ever-increasing pace. New technologies emerge monthly, customer expectations shift almost weekly, and global events can turn well-laid plans upside down overnight. In such a dynamic environment, the ability to adapt, innovate, and deliver value quickly is not just an advantage, it's a necessity. This drive for speed and flexibility is precisely why the Agile Revolution began, and why its principles have since spread far beyond the world of software development. For a long time, the dominant approach to managing complex projects, particularly in software, was what became known as the waterfall model. Picture a mighty river flowing steadily downwards, each cascade representing a distinct phase of a project. Requirements: first, gather all the customer's needs and wishes thoroughly and completely. Design: translate those requirements into a detailed blueprint. Implementation: build the product exactly according to the design. Testing: verify that the finished product works as intended and meets all requirements. Deployment: deliver the final product to the customer. Maintenance: support and fix any issues that arise. On the surface, this sequential, phase-by-phase approach seemed logical and orderly. It offered the perception of control, with a clear plan, extensive documentation at each stage, and distinct handoffs between teams. For simpler, predictable projects with stable requirements, it could even work. Stakeholders would sign off at each gate, confident that everything was clearly defined before moving to the next step. However, the reality of complex projects often deviated sharply from this ideal. The very strengths of Waterfall, its rigidity and emphasis on upfront planning, became its greatest weaknesses in a fast-changing world. Consider a common scenario: a development team embarking on a new customer-facing application. They spend 6 months meticulously gathering every single requirement, designing every screen, and documenting every interaction. The customer signs off on the detailed specifications. Operations begin. 12 months later, after painstaking implementation and exhaustive testing, the shiny new application is finally ready for its grand unveiling. But here's the problem: the market has shifted dramatically. A competitor launched a similar, simpler product 6 months ago, and customers have already adapted to new expectations. Some of the features meticulously built are now obsolete, others are missing entirely, and the initial excitement has long since faded. The project, though technically successful in delivering against its original requirements, delivered a product that no one truly wanted anymore. The team had built the perfect answer to a question that was no longer being asked. This wasn't an isolated incident. Projects often suffered from rigidity. Once a phase was done, going back to make changes was incredibly difficult and costly, like trying to swim upstream against a strong current. Late feedback: customers only saw the product at the very end, leading to major rework if their needs had been misunderstood or had changed over time. Inability to adapt: the world simply moved too fast for fixed-plan projects. New technologies, market trends, or competitive pressures could render carefully crafted plans irrelevant long before completion. Big bang deployments: releasing a massive, untested product all at once carried enormous risk, often leading to significant bugs and user dissatisfaction. Demoralized teams: constant pressure to deliver against an outdated plan, coupled with little customer interaction, often led to frustration and burnout. The business landscape was evolving into what many termed a VUCA world: volatile, uncertain, complex, and ambiguous. In such a world, sticking to a predetermined, immovable plan felt more like walking blindfolded than navigating effectively. Businesses needed to be nimble, to embrace change, and to learn continuously. Even before the phrase Agile became popular, far-sighted thinkers were experimenting with new ways of working. Concepts like lean manufacturing, which focused on eliminating waste and maximizing customer value, gained traction in traditional industries. Ideas around rapid application development and iterative delivery emerged in software. The stage was being set for a profound shift in mindset. It was against this backdrop, in February 2001, that 17 independent-minded software practitioners gathered in a ski resort in Snowbird, Utah. They represented different methodologies and often held differing views, but they shared a common frustration with the traditional approaches and a desire to find a better way to build software. They sought a set of shared values that could guide them through complexity and uncertainty. What emerged from that meeting was the Manifesto for Agile Software Development, a brief but revolutionary document that laid the foundation for what we now understand as Agile. This book explores the how and why of Agile, demystifying its core principles and practices. It will show you why Agile isn't just about software or even just about projects, but about cultivating a mindset of adaptability, collaboration, and continuous improvement that is essential for success in any field in the 21st century. Chapter 2, the Agile Manifesto, uncovering its core values and principles. In the previous chapter, we explored the limitations of traditional, sequential project management approaches, particularly in our increasingly volatile and complex world. We saw how the need for a more adaptable way of working led to a pivotal meeting in 2001, where a group of insightful software developers sought a paradigm shift. What emerged from that gathering in Snowbird, Utah, was the Manifesto for Agile Software Development, now famously known as the Agile Manifesto. This manifesto isn't a detailed instruction manual or a list of steps. Instead, it's a deliberately concise statement built on 4 core values and 12 supporting principles. Its power lies in its simplicity and its profound reorientation of priorities. It doesn't tell you how to do Agile, but what it means to be Agile. Let's unpack these foundational elements. The 4 core values, a declaration of priorities. The manifesto begins with a powerful declaration. We are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. That is, while there is value in the items on the right, we value the items on the left more. This final sentence is crucial. The manifesto doesn't dismiss processes, tools, documentation, contracts, or planning. It simply asserts that, in a world demanding adaptability and speed, the items on the left are more important and should take precedence when choices need to be made. Let's delve into each value. 1. Individuals and interactions over processes and tools. This value emphasizes the human element at the heart of any successful endeavor. No matter how sophisticated a process or a tool might be, it is the people and how effectively they communicate and collaborate that ultimately determine success. A rigid, bureaucratic process, even one supported by cutting-edge software, can stifle creativity and slow down progress if it doesn't prioritize clear, direct communication and the natural interactions between individuals. Practical implications: focus on communication, encourage face-to-face conversations, even virtual ones, daily sync-ups, and open dialogue over lengthy email chains or formal reporting structures. Empower teams. Trust the people doing the work to make decisions and solve problems together. Build relationships. Foster an environment of psychological safety where team members feel comfortable asking questions, admitting mistakes, and openly discussing challenges. Think of it this way: you could have the most beautifully designed kitchen with every modern gadget and a meticulously documented recipe book. But without a talented, communicative team of chefs who can adapt, support each other, and discuss issues on the fly, the food might not be very good, and the kitchen won't be a happy place. The chef's direct communication and problem-solving skills are more valuable than the perfect process diagram. 2. Working software over comprehensive documentation. For years, the success of a project was often measured by the sheer volume of documentation produced. Detailed requirements documents, elaborate design specifications, exhaustive test plans. The problem was that these documents often became outdated quickly, or were misunderstood, or simply gathered dust. Ultimately, customers don't want a stack of binders, they want a product that works. This value shifts the focus to producing tangible results. It means releasing functionality early and often, putting something usable into the hands of users, and gathering direct feedback. While documentation still has its place, it's on the right side of the over. It should be just enough to support the working product and facilitate collaboration, not an end in itself. Practical implications: frequent delivery. Aim to deliver small, functional pieces of a product regularly. Minimize waste. Produce documentation only where it adds clear value and supports the development of working features. Customer feedback. Get real users interacting with the working product as early as possible. Imagine planning a child's birthday party. You could write a 50-page binder detailing every minute and every contingency. Or you could focus on making sure the cake gets baked, the balloons are inflated, and the games are ready. The goal is a fun party for the child, not a perfect binder. Agile aims for the equivalent of a great party, not just a great plan. 3. Customer collaboration over contract negotiation. Traditional projects often involved lengthy contract negotiations up front, attempting to define every conceivable detail and contingency. This often created an adversarial dynamic between the customer and the development team, where each side tried to protect its interests rather than work together for a shared goal. When changes inevitably arose, they became costly change requests, leading to delays and resentment. Agile advocates for a continuous, cooperative dialogue with the customer, treating them as an integral part of the team. This doesn't mean abandoning contracts entirely, but rather fostering a relationship built on trust, transparency, and a shared understanding of evolving needs. Practical implications: regular engagement. Involve customers or their representatives in the development process through frequent reviews and feedback sessions. Shared understanding. Continuously clarify requirements and prioritize features together. Focus on value. Ensure that the product being built genuinely solves the customer's most important problems as they evolve. Consider building a custom home. The traditional way is to sign a fixed-price contract for a detailed blueprint. Any desires to move a wall or change a window after breaking ground become costly change orders. An agile approach would involve the homeowner in weekly walkthroughs, allowing for small adjustments as the house takes shape, fostering collaboration over arguments about the original binding agreement. 4. Responding to change over following a plan. This is perhaps the most radical shift. In waterfall, a deviation from the plan was often seen as a failure. In Agile, change is embraced as an opportunity for improvement and adaptation. In a rapidly evolving world, clinging rigidly to an outdated plan can be disastrous. The ability to pivot, to incorporate new information, and to adjust direction based on feedback is a powerful competitive advantage. This doesn't mean a complete absence of planning. Agile teams plan continuously, but they do so in short cycles, accepting that the plan will evolve. They build in mechanisms to inspect progress frequently and adapt their approach accordingly. Practical implications: iterative development. Work in short, fixed-length cycles, often 1 to 4 weeks, rather than long, multi-month phases. Frequent reevaluation. Regularly review the project's direction and adjust as needed based on new knowledge or changing circumstances. Flexibility. Prioritize the ability to change direction over strict adherence to an initial, potentially flawed, roadmap. Think of navigating using an old paper map versus using a modern GPS. The paper map gives you a fixed plan from start to finish. If a road is closed or traffic is heavy, you're stuck. The GPS, however, continuously reevaluates, incorporates real-time data, and recalculates your route, responding to change to get you to your destination most efficiently. Agile acts like that GPS. The 12 supporting principles, guiding actions. Building upon these 4 values, the Agile Manifesto also provides 12 supporting principles. These offer more specific guidance on how to put the values into practice. While they originated in software development, their universal applicability is striking. Our highest priority is to satisfy the customer through early and continuous delivery of valuable software. Focus on getting value to the customer, not just completing features. Welcome changing requirements, even late in development. Agile processes harness change for the customer's competitive advantage. See changes as opportunities, not problems. Deliver working software frequently, from a couple of weeks to a couple of months, with a preference to the shorter timescale. Keep delivery cycles short and regular. Business people and developers must work together daily throughout the project. Close collaboration between those who define the needs and those who build the solution. Build projects around motivated individuals. Give them the environment and support they need, and trust them to get the job done. Empowering great people leads to great results. The most efficient and effective method of conveying information to and within a development team is face-to-face conversation. Reinforces the individuals and interactions value. Working software is the primary measure of progress. Not hours worked, lines of code, or documents produced, what tangible features are working. Agile processes promote sustainable development. The sponsors, developers, and users should be able to maintain a constant pace indefinitely. Avoid burnout, establish a healthy rhythm. Continuous attention to technical excellence and good design enhances agility. Quality isn't sacrificed for speed, it makes speed sustainable. 10. Simplicity, the art of maximizing the amount of work not done, is essential. Focus on delivering the most important things and eliminate unnecessary complexity. 11. The best architectures, requirements, and designs emerge from self-organizing teams. Trust in the collective intelligence and initiative of the team itself. 12. At regular intervals, the team reflects on how to become more effective, then tunes and adjusts its behavior accordingly. Embrace continuous improvement through regular introspection. The Agile mindset, more than just practices. It's vital to understand that Agile is not just a methodology, a tool, or a checklist of practices. At its heart, Agile is a mindset. It's a way of thinking about work, about people, and about the nature of a project itself. It's an embrace of empiricism, where decisions are based on what is observed and learned, rather than on upfront predictions. It's a commitment to continuous learning, adaptation, and improvement. Many organizations have tried to do Agile by simply adopting some of its practices, perhaps implementing daily stand-ups or writing user stories, without truly internalizing the underlying values and principles. This often leads to frustration and limited results, sometimes referred to as watermelon Agile, green on the outside, but still red on the inside. True agility comes from a deep cultural shift, where individuals and organizations prioritize flexibility, collaboration, and value delivery over rigid plans and processes. The Agile Manifesto laid the philosophical groundwork for a new era of project management. In the following chapters, we will explore some of the specific frameworks that have emerged from these values and principles, allowing teams and organizations to put them into practice and reap the benefits of true agility. Chapter 3, Understanding Scrum, the most popular Agile framework. If the Agile Manifesto provides the philosophical foundation for how to be Agile, then Scrum is one of the most widely adopted and effective frameworks for doing Agile, particularly in software development, but increasingly in many other domains. It provides a lightweight yet powerful structure that embodies the Agile values and principles, making them concrete and actionable. Scrum isn't a silver bullet, nor is it a rigid, step-by-step methodology filled with detailed instructions. Instead, it's a framework built on empiricism, the idea that knowledge comes from experience and making decisions based on what is observed. It provides a simple set of rules, roles, events, and artifacts that allow teams to deliver complex products adaptively and creatively. The beauty of Scrum lies in its intentionally incomplete nature. It gives you the structure, but leaves room for teams to fill in the gaps based on their context and continuous learning. The core idea: iteration and incrementation. At the heart of Scrum is the concept of working in short, fixed-length cycles called sprints. Each sprint is like a mini-project, typically lasting between 1 and 4 weeks, during which a team produces a done, usable, and potentially shippable increment of product. This iterative and incremental approach directly addresses the shortcomings of waterfall mentioned in Chapter 1. Fixed-length cycles provide rhythm and predictability, reducing risk. Done increment ensures regular delivery of tangible value, not just documentation. Inspect and adapt. At the end of each sprint, the team and stakeholders inspect the increment and the process and adapt their plans for the next sprint based on what they've learned. This continuous loop of planning, executing, inspecting, and adapting is what makes Scrum so powerful in environments of high uncertainty and change. The 3 pillars of Scrum: transparency, inspection, adaptation. Scrum is built on the empirical process control theory, which relies on 3 fundamental pillars. Transparency. All aspects of the process must be visible to those responsible for the outcome. This means clear communication, shared understanding of work, and visibility into progress and challenges. No hiding problems, issues are surfaced quickly so they can be addressed. Example: a visual board showing work progress, like a Kanban board, which we'll discuss in Chapter 5, clear definitions of what done means, and open discussions about challenges. Inspection. Scrum teams and stakeholders must frequently inspect the increment of work, their progress toward a sprint goal, and the way they are working. This inspection should not delay progress, but rather be a timely check for variances or unacceptable deviations. Example: reviewing the completed work at the end of a sprint with stakeholders, or a team meeting to discuss how well their processes are working. Adaptation. If, through inspection, a significant deviation from agreed-upon limits is detected, the process or the material being processed must be adjusted. This is about making changes to minimize further deviation, not just identifying problems. Example: deciding to try a new technique in the next sprint based on lessons learned from the previous one, or reprioritizing work based on new customer feedback. These 3 pillars work in concert. Without transparency, inspection is impossible. Without inspection, adaptation is uninformed. And without adaptation, transparency and inspection become meaningless exercises. The Scrum team. Small, cross-functional, self-organizing. A fundamental concept in Scrum is the Scrum team. Unlike traditional structures where individuals might be assigned to different departments, e.g., a design department, a coding department, a testing department, a Scrum team is a small, cohesive unit designed to be cross-functional and self-organizing. Cross-functional means the team possesses all the necessary skills to deliver a done increment without relying on external specialists. They might have developers, testers, designers, and business analysts all working together within the same team. Self-organizing means the team members decide how best to accomplish their work rather than being directed by external managers. They choose the specific tasks to tackle, how to tackle them, and how to collaborate most effectively. This aligns with the Agile principle of build projects around motivated individuals. Give them the environment and support they need, and trust them to get the job done. A Scrum team typically consists of 10 or fewer people. This small size fosters better communication, reduces complexity, and allows the team to be more nimble. Within the Scrum team, there are 3 specific accountabilities. The product owner. This individual is the sole person responsible for maximizing the value of the product resulting from the work of the development team. They do this primarily by managing the product backlog, which we'll discuss more in Chapter 4. The product owner is the voice of the customer and the business, understanding their needs and translating them into clear, prioritized work for the team. They decide what needs to be built. Analogy. Think of the product owner as the chef and visionary for a restaurant. They understand market tastes, listen to customer feedback, conceptualize new dishes, and decide what dishes go on the menu and in what order to maximize the restaurant's success. The Scrum Master. The Scrum Master is a servant leader for the Scrum team and the broader organization. They are not a project manager, nor do they tell the team what to do. Instead, they facilitate the Scrum process, ensuring that Scrum is understood and enacted, and removing impediments that hinder the team's progress. They coach the team in self-management and cross-functionality, help the product owner with effective product backlog management, and guide the organization in its adoption of Scrum. Analogy: the Scrum Master is like the restaurant's highly skilled kitchen manager. They ensure the kitchen has the right equipment, that workflows are efficient, that any internal conflicts are resolved, and that the team follows the best culinary practices. They don't cook the food, that's the development team, but they ensure everything runs smoothly so the chefs can focus on cooking. The development team. This is a group of dedicated individuals who are committed to creating any aspect of a usable increment in each sprint, regardless of their specific skills, e.g., programmer, designer, tester. They are collectively responsible for delivering the done product. They self-organize to determine the best way to turn the product backlog items into a working solution. Analogy: the development team comprises all the individual chefs and kitchen staff, the head chef, line cooks, pastry chefs, dishwashers, who collaboratively prepare the dishes on the menu. They decide amongst themselves who cooks what and how best to prepare each dish to the chef's, product owner's vision. Benefits of Scrum. When implemented effectively, Scrum can bring significant benefits. Faster time to market. By delivering working product increments every sprint, value is released sooner, and feedback is incorporated quickly. Enhanced flexibility and adaptability. The iterative nature allows for rapid pivots in response to changing requirements or market conditions. Improved product quality. Continuous testing and integration, along with frequent feedback, lead to a higher quality product. Increased stakeholder satisfaction. Regular demonstrations and collaboration ensure the product meets true customer needs. Higher team morale. Self-organizing, empowered teams often feel a greater sense of ownership and satisfaction. Earlier risk mitigation. Problems and impediments are identified and addressed much earlier in the product lifecycle. While Scrum is relatively simple to understand, its effective implementation requires discipline, commitment, and a willingness to embrace the empirical mindset. Many teams find the transition challenging, but the rewards are substantial. In the next chapter, we'll dive deeper into the mechanics of Scrum, exploring the specific events, meetings, and artifacts, tangible products of work that define its rhythm and structure. Chapter 4. Diving deeper into Scrum. Roles, events, and artifacts in action. In the previous chapter, we introduced Scrum as a lightweight yet powerful framework for doing Agile, built on the pillars of transparency, inspection, and adaptation. We also explored the structure of the Scrum team with its 3 distinct accountabilities: the product owner, the Scrum master, and the development team. Now, it's time to pull back the curtain and see Scrum in action, understanding the specific events or meetings that give it its rhythm and the artifacts or tangible outputs that provide transparency. These elements work together like the moving parts of a well-oiled machine, creating a continuous loop of planning, execution, inspection, and adaptation that defines the Scrum framework. Scrum events. The rhythmic pulse of the sprint. All events in Scrum are time-boxed, meaning they have a maximum duration to ensure efficiency and focus. Missing an event implies missing an opportunity for inspection and adaptation. 1. The sprint. The sprint is the heartbeat of Scrum. It's a consistent, short, fixed-length period, typically 1 to 4 weeks, during which the Scrum team works to create a done, usable, and potentially shippable increment. Once a sprint begins, its duration is fixed and cannot be shortened or lengthened. Each sprint starts immediately after the conclusion of the previous sprint, creating a continuous flow. Purpose. To turn ideas into value every single sprint. Timebox, max 1 month, often 2 weeks for most teams. 2. Sprint planning. The sprint begins with sprint planning. Here, the entire Scrum team collaborates to plan the work to be performed in the upcoming sprint. This involves answering 3 key questions. Why is this sprint valuable? The product owner proposes how the product could grow in the upcoming sprint, and the team collaborates to define a sprint goal. This goal provides focus and flexibility for the team. Example: if building an online shopping cart, the sprint goal might be enable customers to securely add items to their cart and proceed to checkout. What can be done in this sprint? The development team selects items from the top of the product backlog, the ordered list of work for the product that they believe they can complete to meet the sprint goal. This chosen subset of the product backlog becomes the sprint backlog. How will the chosen work get done? The development team plans the work necessary to create a done increment, breaking down selected product backlog items into smaller, manageable tasks. Purpose: to agree on a realistic and valuable sprint goal and to plan the work for the upcoming sprint. Timebox, max 8 hours for a 1-month sprint, proportionately shorter for shorter sprints. 3. Daily Scrum, daily stand-up. The daily Scrum is a brief, 15-minute event for the development team to synchronize their activities and plan for the next 24 hours. Held at the same time and place each day, it helps surface impediments and coordinate efforts towards the sprint goal. It is not a status meeting for managers. It's a planning meeting for the development team. The Scrum Master ensures the team adheres to the time box and understands the purpose. Traditionally, teams might cover: what did I do yesterday that helped the development team meet the sprint goal? What will I do today to help the development team meet the sprint goal? Do I see any impediment that prevents me or the development team from meeting the sprint goal? Purpose: to inspect progress toward the sprint goal and adapt the sprint backlog as necessary. Example: imagine a team developing an event registration system. During their daily Scrum, one developer might say, "Yesterday, I finished the basic registration form. Today, I'll start linking it to the payment gateway. I'm blocked because I need test credentials from the finance system." This immediately surfaces an impediment that the Scrum Master can help resolve. Time box, max 15 minutes. 4. Sprint review. At the end of the sprint, a sprint review is held to inspect the done increment and adapt the product backlog if needed. It's a collaborative working session where the Scrum team presents the results of their work to key stakeholders, and they all discuss what was accomplished in the sprint and what has changed in their environment. Based on this, attendees collaborate on what to do next. Purpose: to inspect the increment and adapt the product backlog. Example: the team presents a working prototype of the online shopping cart. Stakeholders can click through, add items, and give immediate feedback. "I like this, but can we move the apply coupon box somewhere more prominent?" This feedback directly informs future sprints. Time box: max 4 hours for a 1-month sprint, proportionately shorter for shorter sprints. 5. Sprint retrospective. The sprint retrospective is the final event of the sprint. The Scrum team inspects itself and plans for improvements to be enacted during the next sprint. This is an opportunity for the team to reflect on what went well, what could be improved, and what changes they want to implement in their processes, tools, or interactions. It's a dedicated time for continuous self-improvement for the team itself. Purpose: to plan ways to increase quality and effectiveness. Example: a team might discuss, "We spent too much time waiting for feedback from the marketing team this sprint. For the next sprint, let's schedule a dedicated daily half-hour where they are available for questions." Time box, max 3 hours for a 1-month sprint, proportionately shorter for shorter sprints. Scrum artifacts. Making work and value transparent. Scrum's artifacts represent work or value. They provide transparency and opportunities for inspection and adaptation. 1. Product backlog. The product backlog is an emergent, ordered list of what is needed to improve the product. It is the single source of work to be done by the Scrum team, and the product owner is responsible for its content, availability, and ordering. Items in the product backlog are often expressed as user stories, which we'll cover in Chapter 7, but they might also be bugs, technical work, or knowledge acquisition. It's a living artifact, constantly refined and updated. What it contains: features, functions, requirements, enhancements, and fixes that make up the changes to be made to the product. Key characteristic: continuously refined, groomed, estimated, and prioritized by the product owner with input from the development team. 2. Sprint backlog. The sprint backlog is a forecast by the development team about what functionality will be in the next increment and the work needed to deliver that functionality. It's created during sprint planning. It makes transparent all the work the development team plans to accomplish during the sprint. The sprint backlog is often dynamic, updated by the development team as they learn more during the sprint. What it contains: the product backlog items selected for the current sprint plus the plan for delivering them. Key characteristic: owned solely by the development team, it's their plan for the sprint. 3. Increment. The increment is the sum of all the product backlog items completed during a sprint and the value of the increments of all previous sprints. It is the actual working product, or a usable piece of it, created during a sprint. For an increment to be truly done, it must meet the definition of done, a shared understanding by the Scrum team of the quality standards that must be met for a feature to be considered complete. This definition of done might include tasks like coding, testing, integration, documentation, and compliance checks. If any work item does not meet the definition of done, it cannot be released, even if it is mostly done. What it is: a concrete step toward the product goal. Key characteristic: usable, potentially shippable, and meets the definition of done. The flow of Scrum, a continuous loop. Imagine the Scrum events and artifacts, forming a continuous, dynamic loop. The product backlog, with items prioritized by the product owner, acts as the raw material. Sprint planning kicks off a new sprint, where the team selects items from the product backlog for their sprint backlog and defines a sprint goal. Throughout the sprint, the development team works on the sprint backlog, coordinating daily during the daily Scrum. The Scrum Master assists, removing impediments. As work is completed, it contributes to the increment, which must meet the definition of done. At the end of the sprint review inspects the increment with stakeholders, providing valuable feedback that might lead to adjustments in the product backlog. Finally, the sprint retrospective allows the team to reflect on their process and identify improvements for the next sprint. This cycle never truly ends as long as there is a product to develop and improve. Scrum, through its defined lightweight structure, enables teams to operate empirically, continuously learning and adapting to deliver maximum value in an unpredictable world. While Scrum is incredibly popular, it's not the only Agile framework. In the next chapter, we'll explore Kanban, another powerful approach that offers a different lens through which to view and manage work. Chapter 5, Kanban, visualizing workflow and limiting work in progress. While Scrum provides a structured, time-boxed approach to iterative development, Agile is a broad church, and not every context requires or benefits from fixed sprints. Another highly influential and increasingly popular Agile framework is Kanban. Originating from Toyota's lean manufacturing system, Kanban focuses on continuous flow, optimizing existing processes, and reducing waste, offering a more evolutionary path to agility. Unlike Scrum, which prescribes specific roles, events, and artifacts, Kanban is less prescriptive. It can be applied on top of existing workflows and doesn't demand a radical overhaul of an organization. This flexibility makes it attractive for teams looking for incremental improvement without disrupting their current operations. The core principles of Kanban. Kanban rests on 4 foundational principles that guide its implementation and foster continuous improvement. Start with what you do now. Kanban doesn't require tearing down your current processes, roles, or responsibilities. Instead, it encourages improving your existing workflow incrementally. This reduces the fear of change and makes adoption much smoother. You overlay Kanban principles onto what's already there. Agree to pursue incremental, evolutionary change. Kanban champions small, continuous improvements rather than disruptive, large-scale transformations. This philosophy, called Kaizen in Lean, makes change less threatening and easier to sustain. Respect current roles, responsibilities, and titles. Kanban explicitly acknowledges that existing roles often have value and purpose. It doesn't typically require immediate reorganizations. The focus is on improving the flow of work through those roles. Encourage acts of leadership at all levels. Continuous improvement is everyone's responsibility, not just management's. Kanban encourages individual team members to identify problems, suggest solutions, and take initiative regardless of their formal title. These principles combine to create an environment where change is safer, more predictable, and less likely to encounter significant resistance. The key practices of Kanban. To implement these principles, Kanban employs a set of core practices designed to optimize the flow of value. 1. Visualize the workflow. This is often the first and most striking aspect of Kanban, creating a visual representation of all stages of work. This is typically done using a Kanban board. A Kanban board consists of columns representing the different states or steps in a workflow, e.g., to do, in progress, testing, done. Cards, often sticky notes, represent individual work items, tasks, features, stories, and they move from left to right as they progress through the workflow. Benefit. Visualization makes bottlenecks immediately apparent, highlights where work is stalled, and provides a transparent overview of the entire process for everyone. Example. For a content creation team, a Kanban board might have columns like Ideas, writing, editing, review, ready for publish, published. Each article would be a card moving across the board. 2. Limit work in progress, WIP. This is arguably the most crucial practice in Kanban and relates directly to the lean principle of eliminating waste. Setting a WIP limit means restricting the number of items that can be in any single stage of the workflow at one time. If a column has a WIP limit of, say, 3 items, and there are already 3 items in it, no new items can be pulled into that column until one of the existing items moves to the next stage. Why it's crucial? Focus. It forces people to finish what they've started before starting something new. Reduces context switching. Multitasking actually slows you down. WIP limits encourage focus, improving efficiency and quality. Reveals bottlenecks. When a column consistently hits its WIP limit, it immediately signals a bottleneck in the workflow that needs attention. Promotes collaboration. If a team member finishes their task but the next column is at its WIP limit, they're incentivized to help pull work forward from the bottleneck stage, fostering stronger team collaboration. Analogy. Imagine a highway. If too many cars, work items, try to enter at once, traffic slows to a crawl or stops. A WIP limit is like having specific on-ramps that only allow a certain number of cars on at a time, keeping the traffic, flow of work, moving smoothly. 3. Manage flow. Once the workflow is visualized and WIP limits are set, the focus shifts to optimizing the flow of work. This involves measuring lead time and cycle time. Lead time, the total time from when a request is made until it is delivered to the customer. Cycle time, the time it takes for a work item to move from a specific point in the workflow, e.g., in progress to completion. By tracking these metrics, teams can identify areas where work is slowing down and pinpoint opportunities for improvement. Identifying and eliminating bottlenecks. The Kanban board quickly shows where work piles up. The team can then collaborate to remove the obstacles causing the blockage. Creating a predictable delivery system. Consistent flow leads to more predictable outcomes, allowing teams to forecast completion times with greater accuracy. 4. Make policies explicit. For work to flow smoothly and predictably, the rules governing the workflow must be clear and understood by everyone. This means defining explicit policies for when a work item moves from one column to the next, e.g., definition of done for each stage, how to handle blocked items, rules for prioritizing similar items. Benefit. Explicit policies reduce ambiguity, ensure consistency, and enable team members to work independently while adhering to agreed-upon standards. 5. Implement feedback loops. Just like in Scrum, regular feedback is essential for continuous improvement. Kanban encourages various feedback loops, often through structured meetings known as cadences, though these are less prescriptive than Scrum's events. Examples include daily Kanban meeting, stand-up, a quick sync-up focusing on the flow of work, identifying blocks, and planning how to pull the next items. Service delivery review, reviewed with customer stakeholders to discuss delivery performance and evolving needs. Operations review, reviewing the effectiveness of the Kanban system itself. Strategy review, reviewing the overall strategy and its alignment with delivery capability. 6. Improve collaboratively, evolve experimentally. Kanban encourages a data-driven, scientific approach to process improvement. Teams are encouraged to generate hypotheses about how to improve flow, experiment with changes, measure the results, and then adapt based on what they learn. This culture of continuous, humble improvement empowers teams and individuals to constantly seek better ways of working. Kanban versus Scrum, which to choose? While both Scrum and Kanban are agile frameworks, they have distinct characteristics. Feature Scrum Kanban. Cadence fixed-length sprints, e.g., 2 weeks, continuous flow, no fixed iterations. Approach iterative, time-box delivery in increments evolutionary. Continuous delivery. Primary focus, delivering a potentially shippable increment each sprint optimizing flow. Reducing cycle time, managing WIP. Roles defined product owner, Scrum Master. Development team, no specific roles prescribed, respect current roles. Change is generally discouraged within a sprint. Embraces change at any time, pull system. best suited for projects with clear goals, stable teams, iterative feature delivery, operational work, continuous improvement, managing ongoing services. It is also common for teams to use a hybrid approach, often called Scrumban, combining elements of both. For instance, a team might use Scrum sprints for planning and delivery, but apply Kanban practices like WIP limits and explicit policies within their sprint workflow. Kanban's power lies in its simplicity, its emphasis on visualizing work, and its evolutionary approach to continuous improvement. Whether used on its own or in combination with other methods, it provides a powerful toolkit for optimizing any workflow and creating a more predictable and efficient system for delivering value. Chapter 6, Other Agile Approaches, XP, Lean, and Hybrid Models. We've explored Scrum, the most popular Agile framework, and Kanban, a strong contender focused on flow and continuous delivery. However, the Agile landscape is rich and diverse. It's important to remember that the Agile Manifesto, Chapter 2, provides a set of values and principles, and various methodologies derive from these. No single framework is a perfect fit for every situation. This chapter will introduce you to other significant Agile approaches, such as E-Extreme programming, XP, and Lean software development, and discuss how teams often combine elements from different methodologies to create hybrid models tailored to their specific needs. E-Extreme programming, XP, engineering for quality and agility. E-Extreme programming, XP, is one of the oldest and most influential Agile methodologies, predating the Agile Manifesto itself. Developed by Kent Beck and others, XP is particularly focused on software engineering practices that promote high-quality code and responsiveness to changing customer requirements. If Scrum provides the project management framework, XP provides a robust set of technical practices that complement it, especially for software teams. The E-Extreme in XP refers to taking best practices like code reviews, automated testing, and frequent communication, and pushing them to E-Extreme levels. For example, if code reviews are good, then constant code review, pair programming, is even better. If testing is good, then writing tests before the code, test-driven development, is even better. Key practices of XP. Pair programming, two developers work together at one workstation. One writes code, driver, the other constantly reviews it for strategy and tactics, navigator. They frequently swap roles. This practice dramatically improves code quality, reduces defects, increases knowledge sharing, and builds team cohesion. Test-driven development, TDD. Developers write automated tests before they write the actual code that will fulfill those tests. This forces clear thinking about requirements and design, acts as living documentation, and provides continuous feedback that the code works as expected. We'll touch on this further in Chapter 9. Continuous integration, CI. Developers integrate their code into a shared repository many times a day, typically after every small change. Automated builds and tests run every time code is integrated. This helps detect integration problems early, preventing integration hell at the end of a project. Also covered in Chapter 9. Simple design. Always design for today, not for potential future needs. Focus on the simplest solution that works, and then refactor, improve the internal structure of the code without changing its external behavior incrementally. Refactoring. Continuously restructure existing code to improve its internal design without changing its external functionality. This keeps the code base clean, understandable, and adaptable. Small releases. Deliver working software frequently in very small, rapid increments, e.g., every few days or weeks. This gets immediate feedback and allows for quick adaptation. On-site customer. A real customer or a very close proxy works directly with the development team, answering questions and providing immediate feedback. This ensures the team is always building what the customer truly needs. Collective code ownership. All team members can change any part of the code. This prevents bottlenecks and encourages shared responsibility. Coding standards. The entire team adheres to a common set of coding conventions to ensure consistency and readability. The planning game. A collaborative planning process involving the customer and the developers to quickly determine the most valuable features for the next release. XB is a powerful and disciplined approach for software teams that prioritize technical excellence and direct customer involvement. Its practices can be integrated into other frameworks like Scrum to bolster technical quality. Lean software development, eliminating waste, maximizing value. Lean software development is an adaptation of the lean principles derived from the Toyota Production System, TPS. Its core philosophy is about delivering maximum customer value with minimum waste. TPS famously focuses on identifying and eliminating muta, waste, in manufacturing. Lean software development applies the same rigorous pursuit of efficiency and value to software creation. 7 core principles of lean software development: eliminate waste. Identify and aggressively remove anything that doesn't add value to the customer. In software, waste can include partially done work, unnecessary features, defects, waiting time, idle time, extra processes, context switching, and handoffs. Amplify learning. Software development is a learning process. Foster continuous learning through short iterations, feedback loops like TDD and CI, and frequent customer interaction. Decide as late as possible. Defer irreversible decisions until the last responsible moment. This allows for incorporating more information and adapting to changing realities, reducing the risk of making expensive decisions based on incomplete knowledge. Deliver as fast as possible. Speed is crucial. Fast delivery minimizes lead time, allows for quick feedback, and enables rapid learning cycles. Empower the team. Trust and support the people doing the work. Provide them with the necessary resources, authority, and information to self-organize and make decisions. Build integrity in. Focus on inherent quality from the start, rather than bolting it on at the end. This includes conceptual integrity. The system has a consistent vision, and perceived integrity. It does what the user expects. See the whole. Optimize the entire value stream, from initial idea to deployment and feedback. Don't just optimize individual parts or departments. Ensure the entire system works efficiently together. Lean principles are often integrated into other Agile frameworks. For example, Kanban directly stems from lean principles, visualizing flow, limiting WIP. Scrum's focus on delivering done increments and continuous improvement also aligns with Lean's emphasis on value and learning. Other methodologies, briefly. Feature-driven development, FDD. This is a model-driven, short iteration process that focuses on delivering tangible features every 2 weeks. It emphasizes a structured approach to planning and design, making it suitable for larger, more complex projects. Dynamic Systems Development Method, DSDM. One of the earliest Agile methods, DSDM emphasizes strict adherence to time boxes, integrated testing, and active user involvement. It's often used in corporate environments that require more formal governance. Hybrid models, the best of both worlds. In practice, many organizations don't strictly adhere to a single Agile framework. Instead, they create hybrid models by combining practices and principles from different methodologies. This mix and match approach allows teams to tailor their way of working to their specific context, culture, and project needs. Scrumban. As briefly mentioned in Chapter 5, Scrumban is a popular hybrid that blends the fixed sprints and roles of Scrum with the flow optimization, visualization, and WIP limits of Kanban. A typical Scrumban team might use sprints for planning, reviews, and retrospectives, but manage the work in progress within the sprint using a Kanban board with WIP limits, allowing for more fluid movement of tasks within the sprint. This can be particularly useful for teams with a high volume of unplanned work or those managing ongoing services. Agile plus Waterfall, Wagile/Water Scrum Fall. While often considered an anti-pattern, some organizations attempt to blend Agile development practices within a larger, more traditional waterfall project structure. This often occurs when a traditional program management office, PMO, tries to integrate Agile teams. While it can introduce some flexibility, it often suffers from the core pitfalls of waterfall, late feedback, inability to adapt at the program level, and struggles to fully realize Agile benefits. It's often a transitional stage rather than a desired end state. Agile with DevOps. DevOps, a set of practices that combines software development, dev, and IT operations, ops, is highly complementary to Agile. It extends the Agile focus on continuous delivery and feedback loops beyond development to include deployment and operational monitoring. This ensures that the speed and flexibility achieved in development aren't lost when it comes to getting the product into users' hands and keeping it running smoothly. The key takeaway is that Agile is an umbrella term for a set of values and principles. The specific methodology, or framework, a team uses is a tool to implement those values. Understanding the diverse toolkit available allows teams to choose the most effective approach or combination of approaches to achieve true agility. In the next chapter, we'll delve deeper into essential Agile practices that cut across many of these frameworks, providing practical techniques for everyday Agile work. Chapter 7, Essential Agile Practices, User Stories, Estimation, and Backlog Management. Regardless of whether a team operates primarily with Scrum, Kanban, XP, or a hybrid approach, certain practical techniques have become de facto standards in the Agile world. These practices are the everyday tools that help teams translate the Agile values and principles into tangible work, ensuring clarity, effective planning, and continuous value delivery. In this chapter, we'll dive into 3 such essential practices: crafting user stories, effectively estimating work, and diligently managing the backlog. User stories, capturing requirements from the user's perspective. In traditional development, requirements were often documented in lengthy, detailed specifications that focused on technical functions or system processes. Agile, consistent with its value of individuals and interactions over processes and tools, and customer collaboration over contract negotiation, favors a more human-centric approach. User stories. A user story is a simple, concise description of a feature from the perspective of an end user or customer. It's typically written in a standardized format. As a type of user, I want to perform some action so that I can achieve a goal benefit. Let's break down this format with an example. As a registered customer, identifies who the user is. This helps the team consider the feature from a specific persona's viewpoint, including their needs and permissions. I want to view my past orders, describes the action the user wants to perform. This is the core functionality, so that I can reorder my favorite items quickly. Explains the ultimate goal or benefit the user seeks. This why is crucial. It helps the team understand the value and can often spark better solutions. Why user stories are preferred in Agile. Focus on value. By emphasizing the so that part, user stories ensure that every piece of work delivers a tangible benefit to the end user or business. Teams ask not just what are we building, but why are we building it and who is it helping? Conversation starters. A user story is not a complete functional specification. Rather, it's a promise for a conversation. The brevity of a story encourages the team, developers, testers, product owner to discuss the details directly, asking questions, challenging assumptions, and collectively building a shared understanding. This directly supports the individuals and interactions value. Easy to understand, they are written in plain language, making them accessible to everyone, from stakeholders to the delivery team. Support iterative development. They are typically small enough to be completed within a single sprint or short iteration, supporting the principle of working software over comprehensive documentation and frequent delivery. Characteristics of a good user story. Invest. Bill Wake proposed the INVEST acronym as a mnemonic for remembering the characteristics of good user stories. Independent. As much as possible, stories should be self-contained and not dependent on other stories. This allows for flexible prioritization and development. Negotiable. Stories are not contracts, they are prompts for discussion. The details can be refined during conversations with the team and stakeholders. Valuable. Each story must provide value to the user or business. If it doesn't, it shouldn't be built. Estimable. The team should be able to estimate the effort required to implement the story. If it's too big or unclear, it needs to be broken down or clarified. Small. Stories should be small enough to be completed comfortably within a single sprint. Large stories, often called epics, should be broken down into smaller, manageable user stories. Testable. It must be clear how the story will be tested to confirm it is done and meets the intended functionality. User stories are often written on physical index cards or digitally in backlog management tools, serving as a flexible and potent tool for capturing and organizing work. Estimation in Agile, beyond fixed dates. In traditional project management, effort estimating often involves highly detailed, time-based predictions, e.g., this will take 40 hours, or this module will be done by October 15th. However, in a volatile and complex environment, such precise predictions are often wildly inaccurate and become a source of frustration. Agile teams approach estimation differently. They acknowledge uncertainty and focus on relative sizing rather than absolute time. The goal of Agile estimation is to provide enough foresight for planning without becoming bogged down in false precision. Common Agile estimation techniques, story points. This is the most common Agile estimation unit. Instead of hours or days, teams assign points to user stories based on their relative size, complexity, uncertainty, and effort. How it works: a small, well-understood story might be assigned 1 or 2 points. A story twice as large or complex would be 4 points. Teams often use a modified Fibonacci sequence, 1, 2, 3, 5, 8, 13, 21. For story points, which discourages excessive precision and reflects the increasing uncertainty of larger items. Benefits: focuses on relative size, not duration, which is subject to individual speed and interruptions. Allows for collective team wisdom as the team estimates together. Analogy: imagine trying to estimate how long it will take to eat a variety of fruits. Instead of saying 10 minutes for an apple, you'd say, an apple is a 1. A banana is a 1. A watermelon is an 8, much bigger, more complex to cut and eat. A pineapple is a 13, even more complex, spiky. The points reflect the relative effort, not a fixed time. T-shirt sizing: XS, S, M, L, XL, XXL. A simpler form of relative sizing, often used for initial high-level estimates of larger items, epics, or themes, before they are broken down into detailed user stories. It's quick and fosters a general understanding of magnitude. Planning poker: a collaborative, consensus-based estimation technique. Each team member holds a set of cards, typically with Fibonacci numbers. The product owner reads a user story, answers questions, and then everyone secretly chooses a card representing their estimate. Cards are revealed simultaneously. If estimates vary widely, the team discusses the differences, clarifying assumptions, and then re-estimates until rough consensus is reached. This process harnesses the wisdom of the crowd and uncovers hidden assumptions. Velocity: measuring team capacity. Once a team estimates user stories in story points, they can track their velocity. Velocity is the measure of the amount of work, in story points, a team can complete in a single sprint. By observing velocity over several sprints, teams can predict how much work they can realistically commit to in future sprints. Velocity is a planning tool for the team. It's not a performance metric for individuals. It helps teams forecast future delivery, but it's an average, subject to change. Backlog management: the heartbeat of value delivery. The product backlog is the single, ordered list of everything that might be needed in the product. It is a living artifact, constantly evolving as new information emerges, requirements change, and learning happens. Effective backlog management is critical for the success of any Agile initiative. Key activities in backlog management: product backlog refinement, previously called backlog grooming. This is an ongoing activity where the product owner and the development team collaborate to add detail, estimates, and order to product backlog items. They discuss upcoming items, break large items into smaller ones, and clarify acceptance criteria. This ensures that when sprint planning occurs, the items at the top of the backlog are well understood and ready for development. This is not a formal event, but a continuous collaboration. Prioritization: the product owner is responsible for ordering the product backlog. Items at the top of the backlog should be the most valuable, most ready, and highest priority. Prioritization techniques can range from simple discussions to more structured methods like MOSCOW, categorizing items as must-have, should have, could have, won't have. Value versus effort matrix: plotting items on a graph to visualize what provides high value for low effort, cost of delay, understanding the financial impact of delaying a feature, transparency. The product backlog should be visible and accessible to the entire team and relevant stakeholders. This transparency fosters shared understanding and allows for informed decision-making. Embracing change. A well-managed backlog embraces the Agile principle of responding to change over following a plan. The product backlog is explicitly designed to be flexible. Its contents and ordering can change at any time as new information becomes available, ensuring the team is always working on the most valuable items. These practices user stories for defining work, relative estimation for planning, and continuous backlog management for prioritizing lay the groundwork for effective Agile execution. They provide the practical tools necessary to keep teams focused on customer value, transparent about progress, and adaptable to change, which are hallmarks of true agility. Chapter 8. The Power of Collaboration. Communication, feedback, and team dynamics. At its heart, Agile is a human endeavor. While frameworks like Scrum provide structure, and practices like user stories offer tools, the true magic of Agile unfolds when people connect, communicate, and collaborate effectively. The Agile Manifesto explicitly states, individuals and interactions over processes and tools, underscoring the immense power that good team dynamics, open communication, and continuous feedback loops hold. This chapter dives into these crucial aspects, explaining how they are fostered in Agile environments and why they are non-negotiable for success. Communication, the lifeblood of Agile teams. In a traditional work setting, communication can often be siloed, infrequent, and formalized through written reports or scheduled meetings. Agile, by contrast, thrives on frequent, informal, and direct communication. Face-to-face preference. The Agile Manifesto states, the most efficient and effective method of conveying information to and within a development team is face-to-face conversation. This isn't just about physical proximity, but about the richness of communication when people are conversing directly. It allows for immediate clarification, visual cues, and a higher bandwidth for understanding. In today's distributed world, this translates to video calls with cameras on, encouraging engaged interaction. Example: rather than an email chain about a feature detail, an Agile team would gather around a whiteboard, physical or digital, and discuss it directly, drawing diagrams and asking questions until everyone has a shared understanding. Transparency and open dialogue. Agile teams operate with a high degree of transparency. Problems are surfaced early, not hidden. Difficult conversations are had quickly and professionally. This open dialogue builds trust and ensures that everyone is working with the most current and accurate information. Active listening. Effective communication isn't just about speaking, it's about listening. Agile encourages active listening, where team members truly hear and understand each other's perspectives, concerns, and suggestions. Continuous feedback loops. Learning and adapting. Feedback is the fuel for continuous improvement in Agile. It's not a one-time event, it's a constant stream woven into the fabric of daily work. Internal feedback, team, daily scrums, provide short, daily feedback on progress and impediments within the development team. Pair programming, XP, constant, real-time feedback on code as it's being written. Code reviews, peer-to-peer feedback on completed code. Sprint retrospectives, dedicated sessions for the team to provide feedback to themselves about their processes, tools, and interactions, identifying improvements for the next sprint. This enables a team to truly learn and adapt. External feedback, customer stakeholder. Sprint reviews, regular demonstrations of working software to customers and stakeholders, soliciting their direct feedback and ensuring the team is building the right thing. On-site customer, XP, direct, ongoing access to a customer proxy for immediate clarification and feedback. User acceptance testing, UAT, involving actual users to confirm that the developed features meet their needs. Why is continuous feedback so important? Early problem detection. The sooner an issue, technical, functional, or process-related, is identified, the cheaper and easier it is to fix. Validation and course correction. It ensures that the product being built genuinely solves the customer's problem and that the team's processes are effective. If not, it provides the necessary information for quick course correction. Shared understanding. Feedback sessions foster a deeper, shared understanding among all parties involved. Learning. Each feedback loop is an invaluable learning opportunity, helping the team and stakeholders improve for the future. Self-organizing and cross-functional teams. Empowering the doers. The Agile principle. The best architectures, requirements, and designs emerge from self-organizing teams, is powerful. It challenges the traditional command and control model of management. Self-organizing. An Agile team isn't told how to do its work. Instead, it decides collectively how to best accomplish its goals. This doesn't mean a lack of leadership. Rather, it implies a shift from directive leadership to servant leadership, where leaders, like the Scrum Master, support and enable the team, remove obstacles, and foster an environment where the team can thrive. Benefits. Increased team morale and motivation. Ownership fosters engagement. Faster decision-making. Decisions are made at the source of the work, and often more innovative solutions. Cross-functional. As discussed with Scrum teams, cross-functionality means the team possesses all the necessary skills to deliver a done increment without external dependencies. This includes a mix of technical skills, development, testing, operations, and often a good understanding of the business domain. Benefits. Reduces handoffs and waiting times, fosters knowledge sharing within the team, leading to resilience, and encourages a shared sense of responsibility for the entire product, not just one's own piece. Psychological safety and trust, the foundation. High-performing Agile teams are built on a foundation of trust and psychological safety. Psychological safety. This is the belief that one can speak up without fear of punishment or humiliation. It means feeling safe enough to admit mistakes, ask questions, offer dissenting opinions, or suggest new ideas, knowing that the team will support rather than criticize. Without psychological safety, team members withhold ideas, valuable feedback goes unsaid, and innovation stagnates. Trust. Trust is reciprocal. Team members trust each other to deliver on commitments, to be honest about challenges, and to support one another. Leaders trust their teams to self-organize and make sound decisions. And teams trust their leaders to provide clear goals, remove impediments, and create a supportive environment. Fostering psychological safety and trust requires conscious effort. Leading by example. Leaders and experienced team members model vulnerability and openness. Blameless postmortems/retrospectives, focusing on what went wrong in the system, rather than who is to blame. Empathy and respect, valuing diverse perspectives and treating all team members with dignity. Conflict resolution in Agile teams. Even with high trust and psychological safety, conflict will arise, and that's often a good thing. Healthy conflict, where ideas are debated and challenged respectfully, leads to better solutions. The challenge is to prevent conflict from becoming destructive, personal attacks, passive aggression. Agile teams often employ strategies like direct and timely feedback, addressing issues as they arise rather than letting them fester. Focus on the problem, not the person, framing discussions around the issue at hand. Seeking mutual understanding, ensuring all viewpoints are heard and understood. Scrum Master as facilitator. The Scrum Master often coaches the team through constructive conflict resolution. In conclusion, while the visible practices and structured events of Agile frameworks are important, it's the invisible currents of communication, the relentless pursuit of feedback, and the cultivation of empowered, self-organizing teams built on trust that truly make Agile work. These human-centric elements transform a collection of individuals into a cohesive unit capable of navigating complex challenges and delivering exceptional value. Chapter 9. Quality and Automation in Agile. Testing, continuous integration, and delivery. A common misconception about Agile is that its emphasis on speed and rapid delivery somehow compromises quality. In fact, the opposite is true. Agile doesn't sacrifice quality. It embeds quality throughout the entire development process rather than treating it as an afterthought. This shift from testing at the end to building quality in is fundamental to sustainable agility. By leveraging automation and adopting a whole team approach to quality, Agile teams deliver higher quality products, faster and with less risk. Quality embedded, not bolted on. In traditional models, testing was often a separate phase and a separate department, usually occurring late in the project lifecycle. This meant defects were found late, when they were most expensive to fix, and often led to blame games between development and testing teams. Agile disrupts this by making quality everyone's responsibility, from the moment a requirement is conceived to its deployment. Whole team approach to quality. In Agile, quality is a shared responsibility of the entire Scrum team, product owner, Scrum master, and development team, and often extends to stakeholders. The product owner ensures requirements are clear and valuable, developers write clean code, and testers, who are part of the development team, work collaboratively to ensure all aspects are high quality. There's no QA department to hand off to at the end. Definition of done. As discussed in Chapter 4, the definition of done is a critical artifact. It's a shared understanding within the team of the criteria a work item must meet to be considered truly done. This typically includes quality gates like functional testing, security checks, performance benchmarks, and even documentation standards. This ensures that every increment delivered is releasable. Test-driven development, TDD, building quality from the start. Test-driven development, TDD, is an XBE extreme programming practice that flips the traditional development process on its head. Instead of writing code and then writing tests for it, TDD advocates writing the test before the code. It follows a simple, repeatable cycle known as red-green refactor. Red, write a failing test. Write a small, automated test for a new piece of functionality. This test should fail because the required code hasn't been written yet. Green, write just enough code to pass the test. Write the simplest possible code that makes the failing test pass. Don't worry about perfect design yet. Refactor, improve the code. Once the test passes, improve the code's internal structure without changing its external behavior. Ensure all tests still pass. Repeat this cycle constantly. Benefits of TDD, improved design. Because you consider how to test the code before writing it, it naturally leads to cleaner, more modular, and testable designs. Fewer bugs, the constant testing catches defects immediately, often right after they're introduced. Executable specification. The tests become a living, up-to-date documentation of what the code is supposed to do. Confidence in changes. When you change existing code, you can quickly run all tests to ensure you haven't introduced new bugs. Acceptance test-driven development, ATDD, / behavior-driven development, BDD. Building on TDD, acceptance test-driven development, ATDD, and behavior-driven development, BDD. Extend the concept of test first to the collaboration between developers, testers, and business stakeholders. They focus on defining executable specifications in a human-readable format, often using a given when-then structure before development begins. This ensures that everyone has a clear, shared understanding of the desired behavior from the user's perspective. These specifications often directly translate into automated acceptance tests, ensuring that the software meets the business's expectations. Automation's role: continuous integration and continuous delivery. Automation is a cornerstone of Agile quality. Manual processes are slow, error-prone, and don't scale. Agile teams invest heavily in automating repetitive tasks, particularly in testing and deployment. Continuous integration, CI. Continuous integration, CI, is a practice where developers frequently merge their code changes into a central repository, typically multiple times a day. Each merge triggers an automated build process, which includes running automated tests, unit tests, integration tests, etc. How it works simplified. A developer writes code and runs local tests. They commit their changes to a shared version control system, e.g. Git. A CI server, e.g. Jenkins, GitLab CI, GitHub Actions, automatically detects the change, downloads the latest code, builds the application, and runs all automated tests. If the build or any tests fail, the CI server immediately notifies the team, e.g. via chat, email, and the problem is fixed quickly. Benefits of CI: early detection of issues. Integration problems and bugs are found usually within minutes of being introduced, making them far easier and cheaper to fix than if they festered for days or weeks. Improved code quality incentivizes developers to write cleaner, more modular code for easier integration. Reduced risk makes the code base more stable and reliable. Faster feedback. Developers get immediate feedback on the health of their code. Continuous delivery, CD. Continuous delivery, CD, takes CI a step further. It ensures that the software can be released to production at any time. After a successful CI build, the software is deployed to various environments, e.g., staging, pre-production, where automated and sometimes manual acceptance tests are run. The goal is to have a release pipeline where every change that has passed all automated tests is always ready to be deployed to users. Continuous deployment, CDEP. Continuous deployment, CDEP, automatizes the last step. Every change that successfully passes all stages of the automated pipeline, including all tests, is automatically deployed to production without human intervention. This allows for extremely rapid iterations and feedback loops from real users. Benefits of CI/CD: faster releases. Get new features and bug fixes to users in hours or minutes, not weeks or months. Reduced risk of deployments. Each release contains only a small number of changes, making it easier to troubleshoot if something goes wrong. Automated pipelines reduce human error. Constant feedback. Rapid deployments mean rapid feedback from users, allowing the team to learn and adapt quickly. Improved quality. High levels of automation provide confidence that the software is always working correctly. Technical debt. The silent killer of agility. In the pursuit of speed, teams can sometimes cut corners, such as delaying refactoring, skimping on testing, or ignoring architectural concerns. This creates technical debt, a metaphor borrowed from finance. Just like financial debt, technical debt incurs interest in the form of increased complexity, difficulty in making future changes, higher bug rates, and slower development cycles. Agile teams are acutely aware of technical debt and actively work to manage it. This means prioritizing refactoring, regularly dedicating time to improving the existing codebase, building quality in, not incurring debt in the first place through practices like TDD and CI. Addressing debt, treating technical debt as an important part of the product backlog to be addressed like any other feature. By aggressively embedding quality throughout the process and embracing automation, Agile teams transform quality from a burden into an enabler. This allows them to maintain high quality even as they accelerate delivery, building robust systems that can evolve with changing needs. This focus on internal quality provides the solid foundation necessary for scaling Agile approaches to larger organizations, a topic we will explore next. Chapter 10: Scaling Agile. Adapting Agile for larger organizations and complex projects. So far, we've primarily discussed Agile in the context of a single, small, cross-functional team. While the benefits of agility are profoundly evident at this level, many organizations face the challenge of extending these advantages to larger, more complex initiatives involving numerous teams, departments, or even entire value streams. This is the realm of scaling Agile. Scaling Agile is not simply about doing more Agile. It's about applying Agile principles and practices to coordinate multiple teams working towards a common, larger objective. It addresses questions like, how do 10, 20, or even 100 Agile teams synchronize their efforts? How does a large organization maintain strategic alignment and centralized governance while empowering decentralized Agile teams? Why scale Agile? Organizations scale Agile when a single team cannot deliver an entire product or solution by itself. This typically happens for large, complex products that require multiple skill sets, beyond what a single cross-functional team can provide. Interdependent components, where different parts of a system need to work together seamlessly. Organizational alignment, ensuring that all teams contribute to the same strategic goals. Vast scope, managing programs or portfolios of related initiatives. Challenges of scaling Agile. Scaling Agile introduces its own set of complexities, which are often the reasons why organizations struggle with large-scale Agile transformations. Coordination and synchronization. ensuring multiple teams stay aligned and integrate their work effectively. Communication, maintaining clear and transparent communication channels across numerous teams and organizational layers. Dependency management, identifying and resolving dependencies between teams without resorting to traditional, heavy-handed project management. Organizational structure and culture. Traditional hierarchical structures, functional silos, and command and control cultures often clash with Agile's emphasis on self-organization and cross-functionality. Funding and governance. Adapting budgeting processes, portfolio management, and compliance requirements to an Agile, iterative flow. Consistent application. Ensuring that multiple teams applying Agile frameworks do so effectively and consistently while allowing for local adaptation. Loss of agility. Paradoxically, poorly executed scaling can lead to water scrumfall or overprocess and bureaucracy that negates the benefits of agility at the team level. Key principles of scaling Agile. Despite the challenges, successful scaled Agile implementations often share common principles. Shared vision and strategic alignment. All teams must understand the overarching goal and how their work contributes to it. This provides a North Star for decentralized decision-making. Value stream focus, organizing around the flow of value to the customer, rather than traditional departmental silos. Cross-team coordination events, regular, structured opportunities for multiple teams to synchronize, identify dependencies, and resolve issues. Decentralized decision-making with centralized guidance, empowering teams to make local decisions quickly while providing clear strategic guardrails from leadership. Flow of value end-to-end, optimizing the entire system, from idea generation to deployment and feedback, ensuring that value is delivered continuously and smoothly. Transparency across all levels, making progress, impediments, and plans visible across the entire organization. Continuous learning and improvement at scale, regularly inspecting and adapting practices, not just at the team level, but across the entire system. Overview of popular scaling frameworks. Recognizing the need for structured guidance, several frameworks have emerged to help organizations scale Agile. Each offers a different approach, with varying levels of prescription and focus. 1. Scaled Agile Framework SAFe. SAFe, Scaled Agile Framework, is one of the most widely adopted and comprehensive scaling frameworks. It provides a structured, layered approach for applying Lean Agile principles and practices across an enterprise. Key idea: SAFe organizes multiple Agile teams into an Agile release train, ART, that collectively delivers a larger solution. ARTs are long-lived teams of Agile teams that plan, commit, and execute together. Layers. SAFe defines layers for team, program ARTs, large solution for even bigger solutions, and portfolio, strategic governance and funding. Prescription. SAFe is known for being relatively prescriptive, offering a detailed blueprint with roles, events, and artifacts for each layer. This can be beneficial for large organizations seeking a comprehensive guide, but it can also feel heavy for those seeking a lighter approach. Highlights. Program increment, PI, planning a large in-person event where all teams in an ART plan the next 8 to 12 weeks, inspect and adapt workshops, solution trains, and lean budgeting practices. 2. Large-scale Scrum LSS. LSS, large-scale Scrum, is an attempt to descale the organization rather than scale Scrum. It applies the principles of Scrum to large-scale product development directly, with minimal additional roles and artifacts. Key idea: LSS claims that most problems in large-scale organization are structural. It essentially extends one product owner, one product backlog, and one sprint for multiple Scrum teams. Teams collectively own the product. Flavors: LSS for 2 to 8 teams, and LSS Huge for more than 8 teams. Prescription: LSS is far less prescriptive than SAFe, encouraging teams to figure out their specific implementation details while adhering to a few fundamental rules. It emphasizes simplicity and putting teams first. Highlights: one product owner for the entire product, common sprint, feature teams, and focus on overall product optimization rather than component optimization. 3. Disciplined Agile Delivery, DAD. Disciplined Agile Delivery, DAD, now part of Project Management Institute, PMI, is a comprehensive, context-sensitive toolkit for delivering business solutions. It's less of a framework and more of a process decision framework. Key idea: DAD recognizes that contexts count and that there is no one-size-fits-all solution. It provides a goal-driven approach, guiding organizations through a set of choices and strategies to tailor their Agile approach based on their specific situation and needs. Flexibility: it integrates principles from Scrum, Kanban, Lean, and XP, and allows organizations to pick and choose the strategies that make sense for them across all delivery lifecycle phases: inception, construction, transition. Highlights: focus on pragmatic choices, clear enterprise goals, and process tailoring, emphasizing that teams should be disciplined in their approach, not just doing Agile. Common patterns in scaled Agile. Beyond specific frameworks, successful scaled Agile implementations often adopt common patterns. Teams of teams structure, grouping individual Agile teams into larger units, like arts in SAFe or areas in LSS, to facilitate broader coordination. Regular synchronization events. Beyond the daily Scrum, holding events like Scrum of Scrums, Product Owner Syncs, or Big Room Planning to coordinate dependencies and align across teams. Shared product backlog. Maintaining a single, prioritized backlog for the entire solution, ensuring all teams work towards the same goals. Communities of practice, co-PS, guilds. Groups of individuals with shared technical skills or interests who come together to share knowledge, best practices, and solve common problems across teams. Focus on portfolio management, adapting financial and strategic planning to support an iterative, value-driven flow of initiatives rather than fixed, project-based budgets. Scaling Agile is a complex undertaking that goes far beyond just training teams in Scrum. It requires a significant organizational transformation, affecting culture, leadership, funding, and operational processes. By understanding the principles and exploring different frameworks, organizations can choose a path that best helps them maintain agility and deliver value in a large-scale, complex environment. Of course, no transformation is without its hurdles. In the next chapter, we will discuss common challenges and pitfalls that organizations encounter on their Agile journey. Chapter 11. Common challenges and pitfalls of Agile adoption. Agile is not a silver bullet. While its promise of faster delivery, increased adaptability, and improved quality is compelling, the journey to becoming truly Agile is often fraught with challenges. Many organizations embark on an Agile transformation with high hopes, only to stumble or find themselves performing Agile in name only. A condition sometimes cynically dubbed watermelon Agile, green on the outside, red on the inside, meaning it looks fine on the surface but retains core problems. Understanding these common pitfalls is the first step towards proactively addressing them and navigating a more successful Agile adoption. 1. Organizational resistance to change. The most significant barrier to Agile adoption is often human resistance to change. Agile challenges established norms, power structures, and comfort zones. Fear of loss of control. For management, managers accustomed to traditional command and control models may struggle with empowering self-organizing teams. The perception of losing control over detailed planning or individual task assignments can be threatening. Comfort with existing routines. For employees, shifting to daily stand-ups, continuous feedback, and rapid iterations can feel disruptive and uncomfortable to individuals used to more predictable, slower-paced work. This too shall pass mentality. Some employees and managers may view Agile as just another management fad that will eventually fade, leading to passive resistance. Lack of psychological safety. If teams fear admitting failure or asking for help, they will revert to hiding problems, undermining transparency. 2. Lack of management buy-in and support. Agile transformations require leadership sponsorship, not just lip service. Without genuine buy-in and active support from senior and middle management, an Agile initiative is likely to fail. Lip service versus true commitment. Leadership may declare the organization Agile, but fail to provide the resources, training, or cultural shifts necessary for success. Middle management squeeze. Middle managers often feel squeezed. They may lose their traditional authority over task assignment and process control, yet are not fully prepared for the servant leadership role of empowering teams. Their role isn't obsolete, but it changes fundamentally. Unrealistic expectations. Leadership may expect immediate, dramatic results without understanding the iterative nature of Agile adoption itself. Pushing for velocity numbers without understanding quality or sustainability can lead to burnout and technical debt. 3. Misunderstanding of Agile principles. Agile in name only. Many organizations adopt Agile practices without truly understanding the underlying mindset and principles. This is the classic doing Agile versus being Agile problem. Scrum implementations, a common term for teams that say they're doing Scrum, but they skip retrospectives, but the product owner also micromanages the team, but the increment isn't actually done at the end of the sprint. These deviations erode the empirical process control. Focus on velocity as a performance metric. Misusing velocity, a team-level planning tool, to compare teams or individuals, which can incentivize false reporting, inflate estimates, and ultimately undermine trust and quality. Ignoring technical excellence. Neglecting practices like TDD, CI/CD, and refactoring, discussed in Chapter 9 in the name of speed, leading to accumulating technical debt that eventually slows everything down. Treating iterations as mini waterfalls. Planning every detail up front for an entire sprint, then rigidly executing, rather than embracing flexibility and adaptation within the sprint. 4. Difficulties with estimation and planning. Traditional organizations struggle with Agile's approach to planning and budgeting. Demand for fixed scope, time, and budget. Business stakeholders or sales teams continue to demand upfront, fixed commitments in a world designed for flexibility. This forces teams to make unrealistic promises, leading to frustration and burnout. Lack of trust in relative estimates. Stakeholders may struggle to understand or trust story points, preferring concrete hour or date-based estimates. Portfolio and budgeting challenges. Traditional annual budgeting cycles and project-based funding models do not align with Agile's continuous flow of value and team-based funding. 5. Lack of skilled Agile coaches and Scrum masters. The role of a skilled Scrum master or Agile coach is critical for guiding a team's adoption and maturation. Insufficient coaching. Organizations may underinvest in professional coaching, leaving teams to figure out Agile on their own, often leading to misinterpretations and bad habits. Misconceptions of the role. Sometimes Scrum masters are treated as glorified project managers or administrative assistants, rather than as facilitators, impediment removers, and coaches for the team and organization. Lack of internal expertise. The organization doesn't grow its own internal experts to sustain the transformation. 6. Integration with existing systems and legacy debt. Many organizations have been around for a while and carry significant legacy debt. Older systems, complex architectures, and technical debt that are hard to change. Technical hurdles. Integrating modern Agile development practices with monolithic legacy systems can be challenging and slow. Reluctance to prioritize technical debt. Business may always prioritize new features over refactoring or replatforming, perpetuating the cycle of accumulating technical debt. 7. Over-reliance on tools. While Agile tools, e.g. Jira, Azure DevOps, can be helpful, adopting a tool-first approach without understanding the underlying principles is a common mistake. Tool as a substitute for culture. Believing that simply buying an Agile tool will make an organization Agile. Often, the tool forces a traditional process into an Agile skin. Overconfiguration and complexity. Overcomplicating tools with extensive workflows and custom fields, which adds bureaucracy and hinders agility rather than enabling it. 8. Organizational structure and silos. Agile thrives on cross-functional teams and breaking down silos. Traditional organizations often have deeply entrenched functional or departmental silos that hinder collaboration. Functional silos. Teams organized by skill, e.g., separate UI team, database team, testing team, rather than by product or value stream, leading to numerous handoffs, delays, and a lack of end-to-end ownership. Organizational design. The entire organizational structure needs to evolve to support Agile at scale, moving away from rigid hierarchies to more fluid, network-based structures that enable value flow. Navigating these challenges requires patience, persistence, and a willingness to inspect and adapt the Agile adoption process itself. It demands a significant cultural shift, starting from the top and permeating through every level of the organization. Recognizing these common pitfalls allows leaders and teams to prepare for them, develop strategies for mitigation, and ultimately increase the likelihood of a successful and sustainable Agile transformation. In the final chapter, we'll explore how Agile principles can extend beyond the realm of software, offering a powerful way of thinking for virtually any aspect of life and work. Chapter 12. Beyond Software. Applying Agile principles to life and other industries. When the 17 authors penned the Agile Manifesto in 2001, their focus was explicitly on uncovering better ways of developing software. For years, Agile was largely confined to IT departments. However, as the world has become increasingly fast-paced, complex, and unpredictable, the universal applicability of Agile principles has become strikingly clear. Today, Agile is being embraced by diverse fields, from marketing and human resources to education, healthcare, manufacturing, and even personal productivity. Why has this philosophy transcended its origins? Because the core idea of agility, the ability to create and respond to change, to deal with uncertainty, and to continuously deliver value, is not limited to coding. It's a fundamental human need and a critical organizational capability in the 21st century. The core idea of agility anywhere. At its heart, applying Agile principles beyond software means iterative planning and execution. Instead of big upfront plans, breaking down complex tasks into smaller, manageable chunks that can be tackled in short cycles. Frequent feedback. Continuously seeking input and validation from stakeholders and customers, whoever benefits from the work, allowing for rapid course correction. Continuous adaptation. Embracing change as an opportunity, not a derailment. Responding to new information and shifting priorities quickly. Focus on delivering value, prioritizing tangible outcomes and benefits over simply completing tasks or activities. Transparency and collaboration. Fostering open communication and teamwork. Let's explore some examples of how Agile is transforming various fields. Agile in marketing. Traditional marketing often involved elaborate, long-term campaigns planned months in advance. In the age of social media, real-time analytics, and rapidly shifting consumer preferences, this approach is often too slow and inflexible. Campaign sprints. Marketing teams conduct marketing sprints, e.g., 2-week cycles, to launch mini-campaigns, test different messages, or optimize content. A/B testing. Rapidly test different versions of ads, emails, or landing pages to see what resonates with the audience, and then quickly adapt based on data. Content creation. Using Kanban boards to manage the flow of blog posts, videos, or social media updates, with WIP limits to ensure efficient production. Example: a fashion brand might launch a small social media campaign targeting a specific demographic. After 1 week, they review engagement metrics, feedback, make adjustments to their messaging or platform choice, and then launch an improved version in the next mini-cycle. Agile in human resources, HR. HR, often seen as a compliance-driven function, is discovering how Agile can improve employee experience and organizational effectiveness. Recruitment sprints. Designing recruitment processes as iterative sprints, with rapid feedback from candidates and hiring managers, and continuous refinement of job descriptions or interview questions. Performance feedback. Shifting from annual performance reviews to continuous, real-time feedback loops. Onboarding. Iteratively developing and refining onboarding experiences based on feedback from new hires. Example: an HR team might run a sprint to develop a new training module for leadership. They create a minimum viable product, MVP, of the module, pilot it with a small group of leaders, gather their feedback and observations, and then iterate on the content and delivery method for the next version, rather than spending a year developing a perfect, one-size-fits-all program. Agile in education. Educational institutions, from K-12 to universities, are adopting Agile principles to create more engaging, student-centered learning environments. Project-based learning, PBL. Students work on projects in short cycles, receiving frequent feedback from teachers and peers, adapting their approach, and demonstrating progress incrementally. Curriculum design. Teachers iteratively design and refine curriculum units based on student performance and engagement data. Agile classrooms. Some teachers integrate Scrum or Kanban principles directly into their teaching, with students taking on roles, having daily stand-ups to discuss progress, and conducting retrospectives on their learning process. Example, a college course might assign a complex research project to students. Instead of a single final deadline, students submit portions of the project every 2 weeks, receive detailed feedback, and have opportunities to revise and improve before the next submission. Agile in personal productivity. The principles of Agile can be remarkably effective for managing personal goals, tasks, and even life itself. Personal Kanban boards. Visualizing personal tasks, e.g., to-do, doing, done for chores, job applications, or creative projects on a physical whiteboard or digital tool. WIP limits. Limiting the number of personal tasks you are actively working on at any given time to avoid overwhelm and improve focus. Daily planning. Starting the day with a quick stand-up with yourself, planning the most important tasks for the next 24 hours. Weekly retrospective, reflecting on the past week. What went well? What could be improved? What did I learn? What actions will I take next week? Example. Someone planning a large event like a wedding or house renovation can use a personal Kanban board with defined stages, e.g., research, quotes, booked, prepped, done, prioritizing tasks, limiting WIP, and getting rapid feedback, e.g., from vendors or family members. Other industries embracing agility, healthcare, improving patient care pathways, developing new medical devices, and optimizing administrative processes. Construction. Managing complex construction, projects with greater flexibility and reducing rework through iterative planning and feedback. Nonprofits. Streamlining fundraising campaigns, managing volunteer efforts, and developing community programs more effectively. Government, increasing responsiveness, improving service delivery to citizens, and adapting to policy changes. The future of work is Agile. The proliferation of Agile beyond software is not a passing fad. It reflects a fundamental shift in how organizations and individuals must operate to thrive in a world characterized by complexity and change. Agility cultivates continuous learning, adaptability, effective teamwork, and a relentless focus on delivering value. Whether you are leading a large corporation, working in a small startup, managing a family, or simply trying to optimize your personal life, embracing the core tenets of Agile, adaptability, collaboration, and learning will empower you to navigate uncertainty, solve complex problems, and achieve your goals more effectively. Agile isn't just a set of practices. It's a powerful way of thinking that, once adopted, can transform how you approach challenges and opportunities in every aspect of your life.